Hi, everyone. Good afternoon. It's lovely to be here. Thank you so much for everyone who's joining from home, everyone who's joining in person. It's really a great experience to be back on the stage. I really missed it. Okay. Just a second. I'm looking for my clicker. Here it is. Perfect. OK. So how many people here identify as data engineers? Amazing. How many people identify as data scientists? Cool. How many people build infrastructure because they enjoy building infrastructure for all data purposes? Cool. That's amazing. So you don't need to imagine that. You're just going to step into your previous experience where you were building data pipelines that were part of the company products that you're serving. It was a data product that serves data to customers. You're building a dashboard, or you're building an analytics system, or even you're building an automation based on machine learning. The architecture itself involves running Apache Spark, Delta Lake, Airflow, all the good tools that are available for us today. And you've been working with petabytes of data. How many people here reach the petabytes of data scale? Exabytes? OK, that's all good. Every record in that scale matters. Sometimes we feel like we can drop a lot of the records, but actually, in reality, it's going to harm our accuracy and our data quality as we go forward. So one day, let's say you're tasked with replacing a legacy code. You have a data pipelines. There are multiple tissues connected, the different pipes together, and you have to replace a specific logic. You're new to the code. You never worked with it before. There's some testing system built in, and you try to rely as much as you can on the data, on the testing system that exists in your architecture. But the data system doesn't have all the qualifications of a truly reliable data system, because it doesn't have the volume, variety, and velocity of the actual data. So you make some changes. You do your best. You test the data changes that you did. You push it to staging, you see it's fine, and then you push it to production, and you say, YOLO. Because what can you do, right? You did everything you had to do as a data engineer. And so when you get that phone call from the customer, or someone wakes you up in the night saying, hey, what happened to the dashboard? Why are we seeing this weird behavior? You're not really surprised, right? You've been anticipating it. You knew there were some changes in the legacy code that felt a little bit off. And you knew something like that is going to happen. Does anyone have that experience when they had to replace legacy code? Thank you. All right, so this is actually what we're going to talk about today. We're going to talk about how can we operate in the world where we have these complex data systems that we cannot always rely on and still build, eliminate some of the weaknesses that these systems brings into it. And one of the most known people in our industry that's been supporting Apache Spark from the early beginning said in one of our presentations is don't make assumptions about how Spark works. Underneath the hood, it does so many unexpected things that, things just happen and break. One of the recent features that the community released is actually the adaptive query execution. And if you haven't heard about it, and if you haven't tried it, this is all about speeding up the Spark SQL at runtime. So if we used to have a plan well in advance for Spark to run the different operations, now it's going to dynamically, with each stage of the query, going to decide if it needs to coalesce the different shuffle partitions, if it needs to switch the join strategies, or if it needs to optimize the different skew joins. And that's all happens dynamically on the fly without us knowing that in advance. So as you can imagine, there's a lot of things that can go wrong when we give an engine to make decisions on the fly based on some of the assumptions or some of the data we see there. So what do you think can go wrong with data flows when we have all these moving parts? And in reality, most of us know that everything. We need to push new component logic. We need to introduce new data source. We need to introduce different schema changes. We have schema evolutions. We talked about it a lot here in this conference. We have Spark jobs that accidentally run twice. That can happen too. We might need to change some of the tables relationships keys. Let's say I have 32 tables, and I'm OK replacing 30 of them, changing the relationship, trying to hook everything together, make them work. And then I forget the two that was actually very critical and messed up my whole data pipeline. Or I had some production issue, and I could open up a Databricks notebook. I went into my storage and production and start changing the data under the hood, so either S3, Azure Blob, or SSH into my HDFS machine in order to change it manually. And another thing that always happens at data duplication, if we need to handle that at all. So what all of us do, we try to test as much as we can. We have unit testing, integration testing, system testing, end-to-end testing, a huge suite of testing and regression. A whole field was built around how can we test it better. But many times, we don't trust our own tests, right? We have flaky tests. We have tests that doesn't really cover all the functionality that we have. It doesn't cover the volume and variety that we have. And so many times, we reach the point where we say, I'm going to disagree and commit. I will disagree with the failing test and commit my code to production anyway, because I can. So hi, everyone. My name is Adi. I think maybe some of you already met me online or in different conferences in the world. I recently joined Reverse as an executive to start building the best practices we need in data system. I used to work with machine learning in data systems for over a decade. And now this is what I'm focusing on, is how we can finally bring to the world all the best practices we collected and try and think together how we can improve the systems that we have today in order to build resiliency into these systems. So this is what I want to talk about. I want to talk about how can we borrow the concepts from chaos engineering that comes from the SRE world, that comes from the DevOps world, into the data engineering world. And in one sentence, chaos engineering always practice the discipline of experimenting on software in production. That means for us that we're going to run all this experimentation on production data, which is going to be a very interesting experience for us. Chaos engineering practice 4 different principles. One is defining the steady state. We don't define the what, we don't define the how, we define the what we want to see. We need to acknowledge that there's going to be a variety in the world. It's not everything is going to be perfect. We need to run manual experimentations in production, and we need to be able to automate these experiments in production as well. So all these 4 principles, we're going to see how we can apply them to the world of data. And so if I'm thinking about a steady state, if in the world of SREs is usually the system throughput, the latency, et cetera, in the world of data engineering, I'm looking at data product requirements. So what do I need to serve for the business? What am I building for the business? And what are the end requirements of my customers? And these can be internal customers. Sometimes I will build a dashboard for my executive. I will build a dashboard to make data-driven decisions for a different organization within my organization. Or it can be external. It can be that I'm serving these dashboards to my customers, and actually this is the business that we're doing. And so data product requirements is a relatively new field, new concept that came up. Up until today, we always looked at engineering requirements. And now we finally understand that in order to really assess our products and really assess the way that we build the machines, we don't need to look at the how our engineers are building the machine, but actually at the what we see at the end of the day. So we need to make sure we're baking into it the data quality, the data accuracy, so I can have statistics that is a good distribution between the raw data that gets into the system and the data that I'm exposing later on. If I have no duplication or I need to do dedupe, it's also a good data requirement that I can have. And different SLAs, what the freshness of the data, et cetera. And all that is going to translate into, can I trust the data that I see in production?
You don't want to go for a ride, do you? We could get out of the palace, see the world.
Is it safe?
Sure. Do you trust me?
What?
Do you trust me?
And in the day, we're building data products is serving customers, internal or external. And one of the main criteria that's going to speak of how our data product is actually, can our customers trust this data product that we just produced, and can they run automation on top of it? Even if we build a machine learning model, what does that actually mean from a business point of view? Many times we're facing, I see a lot of data scientists, a lot of data engineers build great software, build great models, but does it actually serve what we need to be served, what we need to serve? So does it actually introduce trust into our system? And you're probably curious and you say, hey, data duplication is actually not such a big thing, but here's a good example of how in 3 lines of codes, I just created a data duplication. Raise a hand if you see why there's a data duplication here. Great, thank you, great. Yeah, so the first line is actually reading a Parquet file. We have some bank transaction. This is the fees that we're paying the banks, right? And so we run some transformation, we do some enrichment, something happens along the lines, and then we need to save it back. However, we saved it in a way that we accidentally wrote append instead of write or overwrite to that data. And so as a user of this customer, as someone who's paying fees, I would probably be charged with double fees that I should. And this is a very small example of how easy it is to make mistakes and how hard it is to test it on the testing systems that we have today, because many times we would look at one unit instead of looking at the whole running of the data again and again. So I actually duplicated. If I have my table, I wrote it again, and since this is Parquet, it's not going to help me with dedupe. So we acknowledge we have a steady state, and now we realize that there are varieties in the world, there are different events that's going to happen. And these different events are going to happen in the space of data. Is going to be all the changes, all the corrupted data, all the data variances that comes in we didn't see, us as human making mistakes, going into the system and starting to deleting things. And so easily we can say bye-bye to our weekend. Once our system reaches a stage where it's not stable, there are different patches all over my production system. There's going to be lots of error. I won't know how to fix them, and it's going to be very hard to recover from it. And so chaos engineering, third principle, speaks about running experimentation inside my production, on top of my production. And for us, that means running experimentation on top of my production data. And if it sounds scary, you're right, because it is. Because no one wants to lose petabyte of data and then explain why they lost all of that data again and again. So what many of us did till now, if we acknowledge that best practice, is actually we start copying the data. We created different buckets or different folders, depending on which file system you're working on, and we started copying the data into multiple parts. So we had kind of the main data, the version that we're exposing to our customers at the end of the day, and then we had another folder calling it V1 or V2 or experiment 1 or experiment 2, and then deploying our new logic to these copies of data. And that works great because it enables us this experimental environment, which is exactly what we wanted. We want to be able to experiment on production scale data. So we start creating these file systems, these notions of different experiment folders inside to make it happen. So we covered the third stage. It means I need to experiment on my data, and now we know how we can experiment on our production data. So the fourth principle and the last one speaks about automating that process. So we experiment, we understand there's variances in the world, we need to do something about it. And so the role of an SRE is always to discover weaknesses in the system, and so is the role of us. We need to understand where is the weakest point inside this data pipeline. And so in order to understand where the weakest point is, we need to start managing the data lifecycle in stages. And this is a relatively new idea that just came up recently, following the different trends that we see in the industry that says, if I have my production, inside my production, how can I build these different data stages in order to expose only the high quality, right, accuracy, good data to my customers? And so if we think about the different stages, all the way from production back to development, we can really start reverse engineering the different things that we need to see there in order to enable it. So if I have something that happened in my production system, I want to be able to roll back from that mistake. If someone woke me up in the middle of the night and I need to recover my production system really fast, the first thing I want to do as a data engineer, roll back to a stable version. That's it. When I wake up in the morning, I can bring back all my colleagues and we can start troubleshooting what really happened there and make sure we're eliminating that weakness from our system so it will never happen to us again, hopefully. Taking a step back from that, we need to enable it. So we need to be able to deploy it. So in order to be able to deploy it, we need to have some version control mechanism. So we already spoke about having multiple folders to hold all that information together, but that actually brings us to the version control. Because if we already have multiple folders for it, that means we can take a step back and say, OK, this is my versions, and this is what I can do. And so I am able to roll back to my previous version. And another step that we can introduce when we are having the version controls in the different versions is accuracy and data quality assurance. Because accuracy and data quality assurance is going to make sure that when I am exposing that data to production, at least I know it has a good accuracy. And you probably wonder why accuracy is important in data. So recently I met with someone who managed Flea. He's basically a pilot. And he said his managers always see a dashboard that has 30 to 40% overbooked for their flights. And while this is right before we're boarding the flight, it's actually the same data after people boarded the flight. So a lot of people actually are sitting on the floors in flights today, which is the data that they see, which is, of course, not true, but this is what is reflected in their dashboards. So data quality here is critical because people are going to make decisions on how many planes they need, for example. Taking another step back to the step of development, just what we talked about. We said, how can we enable that experimentation? How can we enable that debugging of a new logic at that scale? And so experimentation give me the ability to do exactly that. So all I need is all these 3 different stages. And now that I have them, I want to automate the different propagation of moving the data in between these different cycles. So what do you think is the best way to automate data stages propagation in my production? Today, many of us already wrote some bash script or did it manually, mastered the AWS CLI or Azure CLI, depends on your favorite cloud, or HDFS. But what is a better way for us to do it? What we're suggesting today is actually think about it in a branching strategy. So if I have my main branch of data that's exposing data to my customers, I want to have the different features data where I can play along, test some things, try different logic, understand if it makes sense, all of this good stuff. So very similar to source control. So here inside that whole circle, I can do the whole production, deployment, and development throughout one circle. So I can actually think through if I'm happy with the result and if I want to later on expose it. And the reason why we're suggesting that today is actually we want to have separation of control. Many times we bake these quality assurance into our code and make it very hard to change them later on. So we have to go back and update the logic of that Spark job. But we want to be able to separate them from the code. So we want to have one place where we're collecting all the accuracy, all the data quality, all the assurance that we have to make, and then have the Spark code running separately. So if that sounds really familiar, it's because it's not a new concept. We've been using Git for many, many years, writing code, doing source control, version control for everything that we do. And so similar thing we can do with data. It's not exactly the same thing. Of course, there is different scale. There are different problems that has in it. But definitely something we can borrow and see like the different functionalities that are available for us to take advantage of today. And so this is the project. This is an open source project that I'm currently working on. It's called lakeFS. And lakeFS provides this Git-like capabilities for data in order to enable us to run this cycle of data on top of our production. So if you think about all the problems that we have today as data engineers, we're able to recover from mistakes. We're able to develop in isolation, so I can have the different branches that I have. We're able to troubleshoot, do atomic updates, and a day-to-day reprocess. And all of these things wasn't available for us later on. We had to develop all these scripts ourselves. So we thought it's the best idea to actually open source it and bring it to the world so people can take advantage of it. So how does it work under the hood? Under the hood, there is a Merkle tree. Merkle tree is a cryptography tree, which means it only looks at the files that got changed. It doesn't care how it got changed. It looks at that binary file. And so it creates a hashing on top of the binary file to see the difference of what got changed. And it does merge on write. And merge on write means that I can change the file again and again, but only when I finally write it, then it's going to merge it back. So it gives me the capability to actually operate on billions and billions of objects without the fear of losing time or having difficulties to operate on top of it in production. It's really interesting. There's a lot of good technology that was built into it. There's a new data model that the community developed for it as well. I highly recommend going to watch the session on it tomorrow. So tomorrow there is a session about the internals of lakeFS open source project, and then going to show how the data model is able to support all of these billions objects and operate super quickly. It's going to be tomorrow at 10 a.m. Oz is going to present about that. So if we're going back to our world as data engineers, this enables us the typical environment that we want to work with, because that enables us to take advantage of the branching mechanism and kind of copy the data in a shallow copy, so close to zero copy mechanism, and start working on the data and running our code and experiments on that data without harming our production data. So we're saving on costs. We're able to recover from weaknesses much faster. And we're also able to collaborate and debug and troubleshoot everything that happens there. And you're probably asking, OK, this is great. I have time travel. I can do all this stuff on top of tables. This is amazing. One of the main advantages specifically of lakeFS is it's able to roll back and operate on top of multi-tables. So if I need to run only on one table and I can roll back and time travel only on one table, I can have in one commit the capability to roll back over multiple tables altogether. So it looks at the repository level. It doesn't care about the table format. It doesn't care about schema. It can work on all types of data because it runs on binary. All right, let's take a look at the demo. All right, this is always the happy part. So hopefully the demo gods would be with us today. So let's see how this one goes. So this is the lakeFS UI, and we have the repository here. I created a dedicated repository. We have 3 different tables. So we have books data set, which holds all the information on the books in my library, books and genres. You can see I have my branch, so I have my main branch right in there. And I'm going to start tweaking it directly from a Databricks environment because I can. And so I also have a Python client to run operations on top of lakeFS, which enables me to programmatically make decisions and build in the hooks and everything that I need to do. So when I run this, this is going to give me all the list of branches that are available directly in my repository, which is DIS22. And next thing, before I want to start experimenting on my data, I want to build the branch, right? I want to branch out so I can build all the logic, I can tweak it, I can introduce all the chaos in the world that I want, and start operating on that branch of data without harming my production. All right, so after running that, it's going to reflect back here inside my branches. So you can see I have the main branch, and now I have experiment chaos, which is exactly what we're going to do. We're going to try and introduce some chaos into the system and see what happens. All right, the first thing I want to do, I want to do the diff. I want to see what got changed in between the different branches that I'm working on. So when we watch the diff, we know we didn't do anything yet. So we shouldn't have anything there yet. So here we are. And now it's time to load the data. We're working with Parquet, working with Spark. You all know this stuff already. Loading 2 different tables, genres and books. Let's take a look at them. We want to do some data exploration. We only want to look at 10 different rows, see what we have in there. We have some really great books. Probably one of my favorites is Project Metadata by Catwoman, but you can find your favorite books here as well. When we look at genres, we can see the different genres that this book has. You probably experienced the reviving and read the reviving of Zookeeper, who is a drama book, and probably Life After Hadoop, which is a crime book. Thank you. And High Performance Yarn, which is a fiction book. Thank you. All right. Don't we all love books? Let me quickly drop the table I already created, create another one. I have genre. I have, did I run this? Here we are. Perfect. And now I'm going to do a massive, 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 massive operation, which is called join. And join operations are usually a lot of fun. Everyone understands them. You don't need a sticker of the Venn diagram on your desktop because we always remember what exactly left join, inner join, right join, all of this good stuff are there. So immediately after I'm running my join, I want to be able to save that materialized view somewhere because I don't want to lose it. It's a heavy operation to run on. So here I run genre on combining it with books. On a left join, there's some select that I do at the end because there are only some columns that I want to see. And so I'm saving that materialized view, and you can see I'm using the chaos repo path. Because I don't know, maybe I did it right, maybe I did it wrong. I don't really know what happened inside my join. It's Parquet. A lot of things can happen under the hood. And so I write it back. And so when I go here, I can already see inside my experimental branch, I introduce uncommitted changes, similar to how we have with GitHub. I run something, I wrote it back, now it's there. I can decide if I want to commit these changes, what do I want to do with these changes, am I happy with it? Let's give it a try. Cool. So I just committed the changes directly into my experimental branch. So it's only available in my experimental branch, not in main, and it's only there. Let's take a look at what really happened to my data. And in real life, I would probably not going to go and start running data exploration. I don't want to run it one by one. I will look at statistics. I will try and see what really happened to the data looking at numbers and not on the data itself. But here you can see something happened. There's some null fiction book that got in. Something in the join, together with the Parquet, together with the number of rows, the ID, something happened to my data, and I actually introduced nulls into my data, which is great fun. OK, so I want to start running quality checks, right? I want to understand what are the nulls, what happened, what did I introduce. So Spark gives us this amazing function where you can actually start and understand how many nulls or none you had in your data. And so I always enjoy using it. And here I can see I have name, one name that is null, and the ID of the books that is null. Cool. OK, so I know what to look for, right? So I want to look at the count of how many rows I have in the different tables to make sense, right? I want to see if they're similar. I can see in the data set that I combined at the end, I have 17, in genre 17, in books 20. OK, so now I can try and understand what was the challenge, what did I miss. Yeah, I can also do some more data exploration and actually display it and see the different genres that I have. But I realized I made a mistake in my join, and so I want to change it. And this is something that usually in the normal testing, it will be very hard for us to detect. It will be very hard for us to write that query. And most of the time, we will go with YOLO because we really hope we got it right. And join operations are super hard to get right. And so the join operations here, what got changed is actually which table is my left table. So this is the only thing I replaced because I realized I have actually 20 books in my books with the authors and 70 books in genre, which means when I did that join before, I introduced a null value, which I don't want to have. And that happened because of Parquet. In other file format, that might not happen. I tried it with CSV. It doesn't happen there. So let's do another join. And let's see what the nulls that we get here. Right? We want to do quality checking. We want to make sure we didn't introduce any problems into our system. And so yeah, the problem moved from ID, name, into genre. OK, this is something I can handle, because I don't want to fake an ID. I don't want to fake a book name. But maybe I can find some genre that is more applicable to the rest of the books. So I'm running all my qualifications. And now I can actually, Spark gives me the ability to run fill in A, so I can fill up all the non-available fields that I have. And this is exactly what I'm going to leverage here in that case, because it makes sense for my case. And once I'm done, I'm going to look at the difference between the two branches. And after I'm happy with my experimental branch, I've noticed I found a problem. I identify it. I can go back into lakeFS, look at the different commits that I have here, decide to commit the change. So let's say join number 2, and look at compare and see actually that this is the main difference between the experimental chaos and the main branch. And now I can decide if I want to merge them back or not. So here in our case, I do want to merge it back. And this was our successful join where we did, on top of our production data, in production, experimenting with all this good stuff. All right. So I want to say thank you all for listening to me today. It was really great to be here with you all. I want to say lakeFS is an open source, and we have a huge, huge community. We're trusted in more than 1,000 companies that decide to try and adopt lakeFS, where we are very fortunate. And we have more than 4,000 members supporting us from different companies. We would love to get your support as well. If this is a project that you're interested in, you want to continue evolving it together with us, you want to continue building these best practices and bring it back to the world and your colleagues, I would love to have a chat with you and see how we can collaborate and what we can do. We have about 1 minute for questions.
OK, fantastic. I'll choose one here.
I have 2 questions. So first one is, what is the biggest data file you ever put in there? Do you have any trouble with that? And the second one is, what do you have in the pre-commit hook?
The first one was about the data file, the biggest data file that I put into it. And the second one?
Yeah, the size of the data file.
And the second one, come again, sorry?
What would you put in the pre-commit hook for before you commit?
Yeah, so the pre-commit hook enables me to separate the different responsibilities, right? When I have my Spark job, when I'm running my ETL, most of the times I will bake in a lot of quality assurance into it if I remember them. And the quality hooks enables me to separation of control. So it actually enables me to split it up and then have the pre-commit hooks separated there so I can always come back and iterate and add them and collaborate on top of them as a data team and not just go back and continuously change my Java jar. As for the second question, I don't remember exactly, but it has some limitation. What I do recommend is we have a booth here, actually. It's a community booth that we're running. So we have a lot of contributors and a lot of engineers that are working on it daily. So you're most welcome to come join us there, and I'll be more than happy to sit with you and show you the internals as well of lakeFS and how the code works, if that helps.
Okay, thank you, Addie. That concludes the session. Let's give Addie a round of applause. Thanks again.
Thank you.